Hello and welcome to the Life Cycle of a Star revision video from scienceworksheets.co.uk. Please like, subscribe and comment to support the channel. Birth of a star. Stars, including our Sun, are formed from a nebula. A nebula is a cloud of gas and dust. It's mostly gas with some dust. The gas and dust particles in the nebula have mass, so there is gravitational attraction between the particles. Gravity pulls the gas and dust together, causing the material to clump and form a denser region called a protostar. A protostar is a baby star. As the protostar becomes denser, the temperature increases. Once hot and dense enough, nuclear fusion starts in the core. Once fusion of hydrogen into helium begins, a new main sequence star is born, and this process releases huge amounts of energy and light, maintaining the stable size of main sequence stars. Our Sun is a main sequence star and it maintains a relatively stable size. Due to nuclear fusion of hydrogen to helium, there is an outward force of radiation from the core of the star. However, as the star has a mass, there is an inward force of gravity that tries to pull the star inwards. Stars in their main sequence will remain a relatively stable size because the outward force of radiation is balanced by the inward force of gravity. Maintaining the stable size assumes that nuclear fusion continues to provide the outward force of radiation. At the end of the main sequence stage, the hydrogen nuclei run out, so the outward force of radiation decreases. And due to the inward force of gravity, the core of the star collapses, causing the core to heat up. This causes the outer layers to swell, leading to the formation of a red giant or red supergiant. Stars that are of a similar mass to our Sun will form a red giant after their main sequence is finished. Stars that have a mass much greater than our Sun will form a red supergiant once their main sequence has finished. Stars of a similar mass to our Sun, once the hydrogen is used up, the main sequence stage ends, the core collapses and the outer layers swell to form a red giant. At the end of the main sequence, helium will be fused to form other light elements no greater in mass than iron. And once all of the light elements have been fused, all of the fusion stops. There is no longer any outward force due to radiation. The inward force of gravity causes the star to collapse in on itself, heating up to form a white dwarf, and the white dwarf will then cool to form a black dwarf. So we have a summary page here showing the stages from a nebula to protostar to main sequence star to red giant to white dwarf and finally to a black dwarf. Stars much more massive than our Sun. Once the hydrogen is used up, the main sequence stage ends. The core collapses and the outer layers swell to form a red supergiant. The red supergiant will collapse inwards, causing huge amounts of compression. This allows for the fusion of nuclei to form nuclei heavier than iron such as uranium, and then suddenly this compression is reversed in an explosion called a supernova. The supernova will distribute these heavy nuclei. This is why we have uranium on Earth. It's due to a previous supernova. During the supernova, the core of the star is compressed and then the outer layers are flung off. The core is compressed into either a neutron star, or if it's a very massive star that was present, then a black hole is formed. This is a summary showing the changes from a nebula to protostar to main sequence star to red supergiant to supernova and then to either a neutron star or a black hole. Thank you for watching. See our revision notes and practice questions. Link is in the description.